off the one that says whiteboard? That's good. Oh. So we did the front of it. So if you weren't here, all this work is on the video from last time. Ooh, look at all that stuff we did. All right. So now, you want to kind of be, if I give you something that already has a scale, you're not going to plug x equal to 20 in there. That's insane. You're going to probably stick with what's down there. So I always do a combination of negative, 0, and positives when I throw it into an equation, just so I can see how the equation handles those things. So what's a good first value to throw in there? Sure. Throw a -1 in there. Why does it make sense I'm going to make all the x values? I'm going to pick all the x values. I'm not going to pick a y value. Because y is already solved. I like it. So I might as well throw things in for x. So in this case, this probably sounds familiar. The way this is written, x is an input, y is an output. So let me input this thing. See what we get. So this is my first. It would be y equals, how do I rewrite this? Kick ass. What's -3 times -1? 3. And what's 3 plus 2? That's great. All right. What's a good next point to plug in? 0 always is a good point to plug in. And when I do 0, I get y equals -3 times 0 plus 2. I don't understand how people have a -3 survive this. What's -3 times 0? Plus 2. All right, 0 kills whatever it's multiplying. Let it die. What else should I plug in there? No way. All right, plug a 1 in there. Y equals -3 times 1 plus 2. What's -3 times 1? I didn't wait for you. What's -3 plus 2? Does everybody understand what's happening? Where am I getting these freaking numbers from? Well, what could x be? What could x be? Anything. So I'm going to be. So I could make it 18 billion and 7, but I'm not going to because it's not on my scale for one thing, and I don't want to deal with that number. God. So I'm going to make it nice numbers. Like I said, I don't like a combination of negatives and positives and 0. Right? So let's see. 1 goes to -1. And what's one last one we can do? Sure. We're kind of going in that direction, right? -3 times 2. -6 plus 2. -4. I want to point out, is everybody cool with that? There's the word. So I plugged in 2, I plugged in 1, I plugged in 0, I plugged in -1, and I see what I got out. Inputs, outputs. Notice this, so you guys know what direction I'm going in. Do you see that first x is -1? And then the next point has an x of 0. Didn't the x go up by 1? What do the y's do in the meantime? They were 5, they became 2. So what the y's go down by 3. So the y's change down by 3 when I step once on the x-axis, right? So look at the number in front of the x, it's -3. There's a connection there. Some of you guys might, a little preview, we don't have to know this yet. But that -3 number, it's got a specific name, but I always call it like the amplifier. Whatever x does, it's multiplying by it, so y gets amplified that much. So if the x changes by 1, the y is going to change down 3. No, I'm not changing anything about the equation. I'm just pointing out something interesting, a connection between the equation and the pattern that I see in the table. When the x, look at the next point. How much did the, are you going, little dude? Yeah. Right here, this point. How much did the x change from here to here? It went up by 1. How much did the y change? Yes. It went down by 3. Here, how much did the x change? Down 3. So I bet you anything, if there would have been a -4x there instead, if this changed by 1, this would have went down by 4. It's crazy, right? What am I talking about? The idea of slope. Kick ass. Don't worry, we're not there yet. Just a little preview. And now I plot these points. What quadrant is negative 1, 5 in? Second one, because I got to go back 1, up 5. 0, 2. Where's that going to be? Good. Y-axis. 0, 2. 1, negative 1. 2, negative 4. And then, screw it, Jeff, just freehand it. Let's see what happens. That's pretty good for me. So watch, and you can see this visually. Down 3 over 1. Down 3 over 1. Down 3 over 1. It's got a negative slope. This would be bad if it was profit of my company. No, nowadays, what are you talking about? You'll be fine. This is really weird. Anyway, here, you guys try number 5 on your own. Let's see if you guys can handle this. So I want you to make your own graph, pick a smart scale. I'll give you a little hint. It's the x-axis you got to be careful about. Because look what your x's are doing, all kinds of weird shit. Make your own graph and pick a good scale.
Question.
Yes.
You're going to show us how to make all the stuff in the calculator?
Eventually.
Okay.
First, we got to do it by hand.
Alright. So, I remember how to do the denominator. The numerator and the denominator. You see how to do a fraction.
Oh, I see. Fraction, all fraction. This is divided. Watch this. Get the math. See the first thing.
Oh.
Get that. And that's crazy.
Solid.
So that's a fraction means division, but then there's a button that changes it back into a reduced fraction. That's what it means.
Yeah, that's what I should have figured out.
Of course, it costs enough money, you should be able to do that. All right, let me catch up to you guys. So I need to be able to get back to 30, up to 15, all this kind of stuff. So what's a good scale from a x-axis? Yeah, you can do 5, yeah. So 5, 10, 15, 20, 25, 10, 15, 20, 25, 30. And then on the y-axis, they're not changing by that much. I can just go by ones. 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3. You see what I mean by it? The scale is consistent on each axis. It goes by 1s up and down. It goes by 5s left and right. So now you can just find your points. Negative 35 would be negative 35. Little a next to that. 15, 2. 15, 2. And then negative 25, negative 1. So like right there on top of that 4, 2.
These, if we were to find another plot that correlates with C, would that be considered parallel?
Oh, I see, I see. Yeah, these are definitely not points on a line.
Okay.
You could draw a line through A, B, and O, but don't draw lines on these kind of problems. Just plot the points. They don't necessarily line out. If the points come from an equation, they must have some visual pattern to them. Kind of makes there's a relationship then between them, so the pattern should show up after you graph it. And that's really one of the most fundamental reasons we graph anything. It's just another way to look at the function visually. Nice. Sweet. How are we feeling so far with that? This is kind of like graphing basics. Okay, so while I've got that up there, might as well. Here's the green book. page 19. You have it with you. Number 2 at the top, page 19. Everybody see that? Page 19, right at the top. It's like right there. If you don't have a book, you can see mine. So if I was going to finish out this table, they added like an extra column to put the point, which is really unnecessary, right? I mean, I can see the point once I fill these in. Can you guys see how nice it is? What would I do for this first row?
Plug in 0 for x.
Plug in 0 for x. So basically, 4 times 0 is going to be 0. I can just cover it up. You guys see that? So if I do 4 times 0 plus 3y equals 24, 4 times 0 is gone. So I really can just look at that straight up, and then what do you do to solve for y?
Divide by 3.
Divide by 3. So I'm going to get 8. So the point would be 0, 8, but again, I can see it already. There's the point 0, 8. What do I do on the second row?
Plug in 0.
Yeah, so I can just cover up that, and I get 4x equals 24. Divide by 4, I get x is 6. So finding when one value is 0 is kind of awesome. Whatever term that has, it's gone. I put a 0 in for y, times 0 is 0. I just get 4x equals 24. Let me show it to you in case you're freaking out. 4x plus 3 times 0. Right, if I let y be 0. So then this is gone. Divide by 4, I get the 6. So that's the point 6, 0. And of course this last point here, just plug a 3 in for x. So then I would get 12 plus 3y equals 24. Yeah. Well, how do I solve this guy? Yeah, subtract 12. Let me put it down here. 12 plus 3y equals 24. Subtract 12. 3y equals 12. Divide by 3, y is 4. I like it. So then you just plot those points. 0, 8. Where's that going to be? Yeah, on the y-axis up here. I like it. 6, 0. X-axis, it goes 6 and then not up or down at all. And then 3, 4, it makes sense. It's going to be right in the middle of those two. 3, 4, so that they all line up. Kick ass. Bam. I want to do one, just to kind of show you. You don't have to worry about this. I want to show you one problem that's not linear. Just to show you how making a table doesn't really change. So let's look at one that's not a straight line. Let's look at let's do y equals x squared minus 4. So this whole process is not just for straight lines. So I can make a little table. And you guys remember, what did I suggest you should plug in? Definitely do 0, but maybe some negatives. So let me give you this. I would plug in -2, -1, 0, 1, 2. I would plug in all those points. Let's just do this one together. It's a little freakadelic. What do you get when you plug in? See, I put some negatives in, I put 0 in, I put some positives in. The less sure I am about what it looks like, the more points I should use. So what do I get when I put a -2 in? Yeah, -2 squared is 4, minus 4 is 0. When you plug a -1 in, 1 minus 4 is, careful. What's -1 squared?
Oh, it's positive.
Positive 1,
-3.
minus 4, -3. When you plug a 0 in, you get
-4.
-4, because 0 squared is just 0. You plug a 1 in, you're going to get the same thing you got up here. Do you guys see that? Because 1 squared is -1 squared. They're both 1. So I still get negative 3. When I plug a 2 in, I get the same thing I got up here because 2 squared is the same as negative 2 squared. So that's why this thing looks the way it does. It kind of like repeats values. You guys should know the name of this maybe. What's the name of the graph of this? Parabola, I like it. Or parabola. You like to say that. Parabola sounds like you need to get inoculated against it. So then we just plot these points. Negative 2, 0, negative 2, 0. Negative 1, negative 3, negative 1, negative 3. 0, negative 4. 1, 3. And 2, 0. And you can see the shape of it, this little U shape. Yeah. Oh. Okay, so we're not going to focus on parabolas at all. I just want to do that right now. Later we have a whole chapter focused on what's called quadratic equations. Was that bad? What's the most important point on there, in a sense? What's the most kind of like... Starts with a V. Vertex. Kick ass. That's like the turning point, right? So that's the graph of the economy. You know, we're like, please turning point, please turning point. We hope it does that instead of doing like, oh shit. We want it to be a real turning point, right? All right. That's why that's an important point.
The vertex is the y-intercept.
Vertex is like, well, in this case, yes. But I meant more generally, because a parabola doesn't have to be symmetric to the y-axis. Yeah. So the y-intercept isn't always the vertex. But you're right. In this case, they're the same. I like it. But a general vertex is the most important one. Kick ass. By the way, up here, what are my intercepts? What's my y-intercept? 8. Nope. 0, 8, kick ass. That's going to get tired of me saying this, but everything on a line is a point. They must have 2 parts to them. And I'm not just doing that to be picky. That's part of it. But the other part is to save you from yourself. If you write them as points, you won't make silly mistakes later. So what's the x-intercept?
6, 0.
6, 0. Kick ass. So what would every x-intercept look like? That x-intercept is 6, 0. What if it would have hit here instead? What would the intercept have been? 2, 0. What if it would have hit here? So every x-intercept looks like something, comma, 0. Why does it make sense? If I make y 0, I'm not up or down at all. I must be on the x-axis. If I make x 0, I'm not left or right at all. I must be on the y-axis. And if you look back at the table, how did we find the y-intercept?
By making x 0.
By making x freaking 0. Holy shit. So if I flip the page here, get into 3, 3, I just basically got us into 3, 3. The first thing 3, 3 is all about is intercepts. Now real quick, look at this selection here. Before we go into intercepts, which one of these are not linear?
X squared.
Yeah, so the basic idea of any linear function is all the variables have to have a first power. The minute it's anything other than a first power, it's going to be curvy. It's not going to be straight line. Does that make sense? We just saw an example of that with the x squared is curvy. X cubed would be curvy a different way. Square roots would be kind of curvy a different way. Okay, I like it.
2i equals 13, just a straight line.
Yeah, they're all straight lines when you get down to it, but it's just going to be like a flat line, right? Yeah, because in this case, y has to remain at 13 halves. So the height stays the same, so it's just going to be like this. X equals would be like this. That's coming up soon. The 2 special cases. All right, so just tell me right now, what's the y-intercept for this guy?
0, 0.
Yeah, 0, 2 is the y-intercept. What's the x-intercept?
1, 0.
All right, so if I give you the graph, obviously it's easy as hell to find the intercept. You see where they hit the axes. Well, what if I give you, let's see, wherever we get more interesting. Oh, these are on, like this. why they use this tiny little font. Let's see if you guys can put together what we were talking about earlier. What would I do to figure out the x-intercept? Make y 0. In my last math class, I think it was math 696. I had an equation with about 11 variables in it. So if I wanted to find the w-intercept, I would make all the other letters 0. So this idea we're learning right now holds for the rest of math. If you want to find an intercept, make all the other variables 0. That's it. Always. So I don't know why suddenly everybody kind of forgets how to find an intercept. So if I want to find a y-intercept, I make that 0. Because for us, we're only going to have those 2 letters, thank God. We don't have 11 variables. I'm not going to do that to you, don't worry. So if I want to find the x-intercept, I set y to 0. And what you guys get when you do that, put a y 0 in there. So what's this become next here? What's 7 times 0? 0. And then you just divide by 5. X is 7. So what's the x-intercept? 7, 0. What's the y-intercept? How do you find the y-intercept? You make x 0. That's it. That's it. So if I make x 0, I get 5 times 0 minus 7y equals 35. What's 5 times 0?
0.
For some people, this negative disappears. I don't know how you do that kind of magic. That's 0. This is still negative 7y. And then what do you divide by? 7. You get?
0.
Beautiful. 0, negative 5. Because what happens is the people that don't write them as points, they're going to plot the point 7, comma, negative 5. That doesn't make a damn bit of sense. When you say a point, you are saying when x is 7, y is negative 5. That's not true. When x is 7, y was 0. Right? And when x is 0, y was negative 5. Those go together. So don't put these 2 together into 1 point and then be like, what do I do? How do I make a line? I got 1 point. No, you got 2 points. Okay, maybe. So now you just got to plot those 2 points and connect them. So I got the point 7, 0, kabam, and I got the point 0, negative 5, kabam. Holy crap. Oh well. This is my straight line. Okay. So please, dear God, enjoy it when I say find the blank intercept. Oh, thank God. Just make one of them 0. It becomes easy. Now, when they give you the graph, you can't beat this shit. What's the x-intercept on this graph?
Negative 5, comma 0.
Good. Negative 5, 0. What's the y-intercept?
0, 3.
0, 3. Good guess. So when they give you the picture, they're telling you the answer. You just got to write it down. Let me see, where's it get more? Oh, here we go. Sorry. This is where these happen. This was the question earlier. Think about this. There's the equation right there we're going to look at. Y equals 3. What letter is missing? X. So what that means, I just want to keep it on time. What that means is the value of X doesn't change anything. So X can be whatever it wants to be. Well, what's the equation say about Y? Y has to be 3. So try to write a few points down. So Y's got to be 3, right? And X can be anything it wants to be because it's not constrained. So what if X was negative 1? What's Y?
3.
3. What if X was 0? What's Y?
3.
What if X was 1? What's Y?
3.
Because the freaking equation says Y is always 3. Now watch. I love that you get a kick out of it. So if you plot these points, negative 1, 3, 0, 3, 1, 3, it should make sense. Which variable controls up and down? The y variable controls up and down, because the y-axis is the one that goes up and down, right? When y changes, don't it go up or down? If the equation says y is 3, that means I have to remain at that height. That's why it turns out to be a horizontal line. So I bet you anything x equals something is going to be a vertical line, because then I'm saying you can't move left to right. You got to have an x stationary. So see, can we just do this one without the table? X equals -4.
Just draw a line.
Yeah, x has got to stay -4, so it's got to stay -4, so it's got to be this line. Every point on this line, pretend like it's straight. If I look up there, it's all free. Every point on that line is going to have an x of -4, so it's going to follow what that equation wants. Do you see how it's not dependent on y? As y changes, does the x give a shit? No, because it doesn't even show up in the equation. The y has no say. Maybe. So those are special cases. They're easy if you remember they're special cases. What's the intercepts of this line here? What intercept do you see? What axis does this line hit? X-axis. Where does it hit it? What's the point again? -4, 0. Kick ass. What about a y-intercept? Does it have a y-intercept?
No.
It is how related to the y-axis?
Parallel.
Parallel. Which means it's never going to hit it. So it's got no y-intercepts. And of course the reverse is true up here, right? It's got a y-intercept but no x-intercept. Poor little dude. Okay, so if I said x equals 20, what kind of line would that be? Horizontal or vertical?
Vertical.
Vertical. X equals means it's got an x, you can't move left to right, so it can only move up and down. That's the best way to look at it. Y equals, it can't move up and down. It's got to stay at a certain y, so it can only move left to right. So hopefully that helps you keep those two straight. Those should be quick. Barely any work needed. Blah, 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 blah. What's the equation of this line? Where'd it go? Here it is. Page 23. X equals -5. Beautiful. I lied. Can't. Let me see. Oh, good. Perfect. All right. Trying to rush there at the end because it's almost time to go. That's exactly how far I wanted to make it. So on Monday, we'll talk about section 3-4. I will have the practice test. When's the test? Wednesday. So on Monday, I'll hand out the practice test. On Tuesday, I'll have the answer key for that. On Tuesday, no new material, just review for the test. And then, of course, Wednesday is the test. What? No. That's me. 3-4. The test is going to go through 3-4. Yeah. Don't forget your IDs and my top letters. Yeah.
So, turn on this.